Good afternoon, President Chan, President Tang, and Professor Chow. And ladies and gentlemen, welcome to this distinguished lecture series organized by the PolyU Academy for Interdisciplinary Research, or we call PAIR. My name is Ching-chuen, the director of PAIR. So PAIR organized this series from time to time, especially after the pandemics. We are able to do this just offline, and we are so pleased to see so many people coming here today. So for many people who don't know PAIR, PAIR was originally from one research institute that's called Research Institute for Sustainable Urban Development, established by President Tang. At that time, he was the dean of FCE in 2013. And after he came to back as the president, he decided to just copy the success. And currently, we have 11 research institutes and 7 research centers. So PAIR works on 3 major fields. The first one is sustainable cities, and the second one is advanced technologies, and the third one is well-being and health. If you are more interested in what we are doing, we have a website you can browse. And today, I would like to ask our president, TENG Jin-Guang, to give an introduction to our distinguished speaker, Professor Chan. Thank you.
Colleagues, students, ladies and gentlemen, welcome to this special PAIR's distinguished lecture. And on behalf of the Hong Kong Polytechnic University, it is our great pleasure to host this particular lecture. Of course, the PAIR Distinguished Lecture has been running as a series, so if you pay attention to our announcements, you will have the opportunity to come to see us from time to time. The university, of course, has a long history, but as a university, as an institution, we have a history of 87 years. But as a university, we actually this year we are celebrating its 30th anniversary, and over the last 30 years, and throughout that period, I've been at PolyU. So we have gone through a major transformation, and by this time, we are positioning ourselves as a world-class, innovative university. So by that, we have 3 dimensions. We want our graduates to be leaders of innovation. We want our research to lead to innovations that benefit society directly, and we want to embed the spirit of innovation in every endeavor of the university. So we always try to measure ourselves against these 3 criteria in terms of becoming an innovative world-class university. And one of the things we have been, we are very happy to do is to conduct impactful research, both of basic and applied nature, through PAIR, which stands for the PolyU Academy for Interdisciplinary Research. In Chinese, we actually call it 香港理工大學高等研究院. Okay, so this is our major platform for interdisciplinary research and as well as technology transfer. So today we are very pleased to have Professor C.C. Chen as a speaker for the distinguished lecture of PAIR. And the topic of his presentation is New Journey of the Energy Revolution and Automotive Revolution. In fact, we just had on Saturday, we had our graduation ceremony where Professor Chen gave a very inspiring speech to our PhD graduates. And I have seen some very complimentary messages sent to Professor Chen via our academic registrar. So the students were very inspired by his speech. So I'm sure you will learn a lot also from his presentation today. Now, Professor C.C. Chen is now a distinguished chair professor of electric vehicles and smart energy in the Department of Electrical and Electronic Engineering at PolyU. He is also director of the Research Center for EVs at PolyU. In fact, at PolyU, we only have two professors named as distinguished chair professors. He's one of them. His contribution to the theory, practice, and public awareness of engineering are very significant and extensive. And his main contribution, I think, is in the area of modern electrical vehicles, devices and vehicles. And his achievements have been recognized by many awards and honors. I'm not going to go through the long list. So let me just mention two things. One is that he was the first person in Hong Kong elected as an academician of the Chinese Academy of Engineering. This is very difficult, so very special honor for him. And also he was named as the father of Asian electric vehicles and grandfather of electric vehicle technology in the media. Professor Cheng's career spans academia, industry, and society at large. He has worked for over 40 years in universities, devoted to teaching and research in electrical engineering, and for over 10 years in industry, focusing on the research and development of electric machines and power systems. He actively advises government agencies, academic institutions, and industries worldwide. He is also the founder or co-founder of several scientific establishments, including the International Research Center for Electric Vehicles, the World Electric Vehicle Association, the International Academy for Advanced Study in China, and the International Academicians Science and Technology Innovation Center. Professor Cheng integrates the strengths of Eastern and Western approaches to foster the advancement of science and technology with the aim of improving human welfare. His impactful contributions over the decades truly exemplify PolyU's motto, to learn and to apply for the benefit of mankind. Without further ado, ladies and gentlemen, please join me in welcoming our distinguished speaker, Professor C.C. Cheng. Thank you.
Thank you, Professor Tang. You have very busy schedule and still come here to introduce me. Thank you so much. Vice President Christopher and our host, Professor Chen, and ladies and gentlemen, I saw many old friends here. So I am so pleased to see so many old friends here. So today I will share with you about the new journey of energy revolution and automotive revolutions. What is the new journey of energy revolution? As you know, energy revolution, first we must go to low carbon neutrality, and then intelligence. And then the end users go to electricity because electricity is more efficient, and to hydrogen. But what is the new journey? The new journey is how you can have reliable and new energy. New energy is very beauty. New energy, wind, solar is so beauty. No pollutions, okay, and sustainable. However, it is very naughty because it's irregular. Today, sunshine very good, but in the evening, no sunshine. So when we apply new energy, when we apply solar and wind, we must also apply storage. But storage is not easy. So some storage is very dangerous. So in addition to storage, we must also put hydrogen. But hydrogen is not easy to transport. So in addition to hydrogen, we also put ammonia and methanol. So by using of the multi-energy storage, we can optimize. That is the new journey of the energy revolution. And what is the new journey of automotive revolutions? As you know, automotive has been here, the IC engine has been for over a century. Okay. However, it has a problem. Okay. So we must go to the electric vehicles. But what is the new journey of electric vehicles? in addition to electrification, to change the ICE to motor, but we must also go to intelligence and connected, to be an intelligent connected vehicle. That is the new journey of automotive revolutions. Okay, so I will talk 7 topics. So the first one, I will talk what is science, what is engineering, and how science engineering push the economy. The third one just very briefly mentions the carbon neutrality and focus on what is the energy revolutions. And the third part, I would like to highlight what is the new journey of EV revolutions. And the fourth part is the EV powertrains, the EV battery, and then the ICV. ICV means intelligent connected vehicles. Then the last one, I will introduce my recent works on for network for flows, because I think automotive revolution cannot be alone. Automotive revolution must be connected with the energy revolution, with the information revolutions, and the superstructure, 上层建筑, the humanity and 经济基础 should be linked together. So there is 4 network. 4 network is energy network, information network, transportation network, and humanity network. 4 flows is that energy flow, information flow, material flow, because energy and matter sometimes can be switched, such as hydrogen. Hydrogen is energy, it also materials, it also is matter. So energy flow, information flow, material and value flow, we have to check whether it have a value or not, it's economy. So this is the last. So the philosophy is we must integrate the 3 worlds. That is the physical world, the cyber world, and the humanity world. Okay, so let me see, let us start from what is science, what is engineering, and how science and engineering push the economy. What is science? Science is truth. It's very simple. Science is truth. Science is seeking, the scientist is seeking for answering why. What is engineering? Engineering is integration of science, technology, and management. As an engineer, we must be able to manage because we want to implement it. So engineering is answering how, and technology is a skill. Okay, so what is the spirit of engineering? The spirit of engineering is freedom of inquiry, independent thinking. And what is the methodology of science? The methodology of science is threefold. First, is your thinking, it's logical thinking. Second is deductive calculation. Third, you have been able to make experimental verification. And the future of science is science has no boundary because it's truth. Truth is suitable everywhere. 方知四海皆准，因为它是真理，真理是方知四海皆准。So it's no national boundary, but science has motherland, and science is no limit. So someone expressed, when I should be retired? It's no retirement for scientists. 只要你的生命还在跳动，你要把自然界的规律找出来啊。Okay, so this is a very well-known painting in Europe, which express the spirit of freedom of inquiry. You can see in the middle, that is the master of that time, Aristotle and Plato. When they come to the all, they are quarreling. They are quarreling. Everybody is independent thinking. That is the spirit of Ravel School of Athens. I love my teacher, but I trust the truth book. Okay, so what is engineering? I promote the engineering philosophy. What is the engineering philosophy? The engineering philosophy is system integration. So in the engineering philosophy, we must, unity must be collaboration in industry. That is what is our president promoted. In fact, tomorrow I will join Christopher. He will lead us to Fujian. We want to set up a technology research center. Yeah, tomorrow he will lead the delegation. PolyU will set up many research center or research institution in many cities, not only in China, but as well. That is to promote the collaboration of unity in industry. Why? because we scientists doing research, publish paper. What is the purpose? The purpose is for the mankind. So you have to be able to transfer your paper to economy, to push the industry. Otherwise, your paper become rubbish. So that is why in the university and industry must collaborate to transfer from science to technology, from technology to production, from the product to commodity. Okay, so we must integrate science, technology, industry, and finance. So in the science, first we must have objective. That is different with scientists, because sometimes it's no objective, because science is just for curiosity. No, but as an engineer, we must have objective. Not objective, we must learn from the science, we must have a thought, we must have the methodology, and we should be able to implement. So I have summarized the 6 points of engineering philosophy. The first point is objective. After the first point, 2, 3, 4 is your thought. The most important thought is holistic thinking. In Saturday in graduation, what is holistic thinking? I think can be expressed by the Chinese philosophy of 易境, 太极平衡。你看那个易经里面太极是一半是黑，一半是白，但是不是直线，是弯曲的，就是白也可以变成黑，黑可以变成白，白中有黑，黑中。That is the holistic thinking. The most important holistic thinking, closed loop thinking, cycle thinking. Today we not only understand concept, but we should understand the related thinking. We should have creative thinking. We should be able to divide and combine and rule. So first is the objective. 2, 3, 4 is your thought. Then you have methodology can be implemented. So 5, 6 is to implement it. To implement, you must consider the human factor. You must promote the teamwork. So I summarize the engineering philosophy with 3 points. And then the difference between science and engineering. Engineers should have experience. Engineers should practice. Okay, so now we have gone through in the human history, we go through from the 18th century, 60s, agriculture economy, the social production, which mainly is based on family-based and self-sufficient. Then we move to the 19th century, 70s, that is the industrial economy. The era of industrial economy mainly is a socialized large-scale production. And then we now enter to the 21st century is the digital economy. In the digital economy, the resource of getting rich are information. So in this century, in this digital economy, computing power is the core competitiveness. Okay, so now in the world of science, there is infinite possibilities. So you can see our potential is infinitive. Our prospect is infinitive. Our imagination is infinitive. The advancement of science and technology constantly expand our knowledge, enhance our productivity, and will inevitably create many exciting possibilities. That is why we have PAIR. Is that correct? That is why we have PAIR here, led by Professor Chen. Because in the world of science, that is infinite possibility. So you can see the innovation exploration constantly push forward, seeking new knowledge, new technology, new application, surpass existing limitation, break through traditional modes of thinking, and create new fields. Okay, so interdisciplinary collaboration. That is why I pair, because interdisciplinary collaboration is very important. The intersection and integration of different disciplines accelerate scientific progress and generate innovative and practical. That is why we have Dr. Chen to lead the pair here. Okay, so also we have to note the ethics. The ethic and the sustainable development, create a path for a better and sustainable future for both humanity and the planet. Okay, okay. So what is the important element of innovation? What is innovation? I think innovation has 3 characters. First is uniqueness. Second is super safe. And thirdly is optimal. And what is the characteristics of innovative talent? 这个创新人才有什么特征？ First, we must have a good foundation, solid foundation in mathematics, physics, chemistry, and humanity. Third, 第一，你要有扎实的基础。Second, we have the sharp perspective， 要有敏锐的观察力。Because your foundation is good, after you have a sharp perspective, you can make in-depth analysis. If your foundation is not good, you can observe, but you cannot analyze. So you must have a good foundation and have sharp perspective, and then you should be able to analyze to the from the original 无人区 the 没有人区 you can find what is the original discovery. In this state, you must have the courage to express. For instance, when you are young, when you publish paper, even myself, when I was also rejected by people. Don't disappoint it. Don't feel disappointed because maybe the reviewer don't understand what you wrote because you are very original. Or your reviewer is frightened. So young, guys is so young, is frightened by you. So please don't disappoint them. I think when I was in Berkeley, who invented the fuzzy logic, Zade, he told me, Zade, you know Zade, he told me his paper was also rejected because people said, you are mad because there's no fuzzy logic at that time. That is in 1889, I was in Berkeley, and he's my neighbor, Zade in Berkeley. Okay. So I say we scientists, of course, in the university, published paper is very important because if you do that paper, you cannot to be promoted. However, only paper is useless. Only paper after a few years, paper become rubbish. So how we can transfer from basic research to applied research, from science to engineering technology, and how we can interlink with the high-tech company, and how can link with the finance to get support. That is the ecological change. Is the ecological change. Okay, so, sorry. Okay, now there are 4 base areas in the world. Of course, the old one is very well known, is Silicon Valley. That is in the San Francisco, Stanford and Berkeley is there. The features is finance plus high tech. Then we have the New York Bay. The New York Bay, the features is finance plus high-end service. And then we have the Tokyo Bay. That is finance plus high-end manufacturing. And now we have the new one, the Guangdong, Hong Kong, Macau, Greater Bay Area. Our size, the geographical size, the economic size, the population is much greater than the sum of 3. However, one thing we are lacking. I have, with Professor Sun in Hong Kong U, I have made a survey. So the ecology is still lag behind the Silicon Valley. As you know, okay, the red one is the research, in the university. The blue one, the deep blue is industry. How we can transfer the research to industry. We need environment. That is the upper door. We need environment. This is called innovation ecosystem. In Hong Kong, there are 4 factors, as I say, basic research, applied research, and then high-tech industry, and then finance. Among the 4 factors, Hong Kong only 2 is good. Basic research is good, finance is good. But in the high-tech industry, we lag behind of Shenzhen. In the applied research, we also lag behind. So we must hand in hand with Shenzhen to make our ecosystem, better. That is the figures, because I have that is the figures, the score of 3B. GBA, Tokyo, San Francisco, New York. Our scientific infrastructure, we are lag behind. So we must work hard to hand in hand to work with Shenzhen to make our scientific infrastructure better and better. Okay. So we must fully use our advantage that the central government given to Hong Kong, rely on the motherland and connecting the world. Hong Kong's capitalist system, Hong Kong legal system. Hong Kong originally have a 3 centers: International Trade Center, Shipping Center, and Financial Center. And now we have to have at new 2 centers, that is Innovation and Technology Center and Culture Exchange Center. And we have to fully utilize our good business environment, our top universities, and our innovative technology and talents. The perfect combination of Hong Kong and Guangdong creates an international talent paradise and a world innovation highland. Okay, so we must also utilize, actively engage in the Silk Road, Belt and Road. You see, because in the Belt and Road, not just only policy, but we also have public sentiment, have a currency transmission, transportation, and trade. In this sense, Hong Kong can play active role, can the active role to engage in the Belt and Road active initiative. Now, the second part, I will talk about the carbon neutrality and energy revolutions. Okay. So this is the dual carbon target, the Paris Agreement. Okay, and then you can see that from the from the peak to the neutrality. In fact, Europe, on the last century 18, they already reached the peak, and the target is 2050 reach the neutrality. And then in the United States, in the 2007, they already reached the peak, carbon peak, and they target also 2050. And Japan, 2008, they already reached the peak, and the neutrality is 2050. Hong Kong also the same. Hong Kong target is also 2050 neutrality. But China is developed very fast, because so they need energy. So they have carbon emission. So in China, now it's still going up. Until 2030, China will reach the peak. And then in 2060, 10 years later, China will reach carbon neutrality. So from the peak to the neutrality, China only have 30 years, while Europe and India have more long years. So China needs more innovation. That is why the Fujian government asked us to go to there to help them, to how to within 30 years, China from the peak will go to the neutrality. So it's energy revolution. What is the core challenge? You know, the objective or the core of the objective is sustainable, reliable, and affordable. And the solution is low carbonized. It's not enough. We must intelligent. We must have the electrification and hydrogen and multi energy hand in hand, right? Multi-energy hand in hand. So China's total carbon emission are approximately 12.3 million tons, with energy-related activity accounting for nearly 90%. The key to realizing the dual carbon goal is energy transition, and the fundamental path of this transition is realizing 2 substitute from energy production to consumption. So from the production side to the consumption side, we must have substitute how to reduce the carbon. So I use an example. Of course, the electric power is the most important one. So how China will build a new power system based renewable energy system? As I mentioned, our target should be clean, low carbon. However, it must also safe and efficient. It's not easy. As you can see, wind and power, it is clean, low carbon, but it is not so reliable because it is fluctuating. So how in order to tackle these assets, we must use multi-source complementary. That is the power supply network low energy storage coordination, or in Chinese we say 源王合处. Yuan is supply, 源王 is network, distributed. 源王合 is load, 源王合处 energy storage. The key word is coordination. Whether you can coordination and make it flexible and intellect, so that means you can balance between the randomly fluctuating supply and demand. From the supply side, this is the supply side, to the distribution side, to the utilization side. We have this very flexible coordination, coordination. Okay, so the principle energy pull out oil reduction, gas weaken. Okay, and then new energy transformation, solar, wind, geothermal, hydrogen, other clear energy. Okay, and then green hydrogen industry roadmap. Okay, and okay, from the urban to the rural to the enterprise, the energy circle, transportation, industry, construction. So all this we must move from the originally rely on the carbon and go to the carbon neutralizations. Okay, so we should pursue zero carbon transformation and development. I was amazed by last month. I was go to Jilin province, and they appoint me as the advisor of this project, and I was amazed because this is a real project. This is not on the paper. A real project with a huge investment. So they will convert. That is originally is a waste coal mine, because the coal mine is already empty. So how to use this place? So this is a green restoration of abandoned mine pits. They have the wind, they have the solar, they have the storage, and among the storage they have a gravity storage, because the geography depend on your geography, because they have the there are many of storage, and one of the storage is gravity storage. And hydrogen is not enough because hydrogen is difficult to move. So you must have swapping. How to swap hydrogen? You plus ammonia and plus methanol. So this is the integration of wind, solar, solid, hydrogen, ammonia, and methanol. This is not empty talk, because this is a real project. The groundbreaking is last groundbreaking ceremony last month. I attended the groundbreaking ceremony, and the investment is renminbi 28.6 billion. 26 billion. That is the next year will be next year will be ready. So next year you can see again. Next year will be like this. Will be commissioned next year, and this is the production of the hydrogen. This is the production of green hydrogen with the ammonia and the methanol. Okay, so this is a hybrid energy solution system. Okay, so then the third part, I will talk about the new journey of the EV revolution. As you know, EV revolution, if we are from electrification, we go to intelligent, we go to connected. We have a proverb say, mobility is freedom. Mobility is the most apt expression for our quest for happiness. Why? In the 19th century, people from the whole life, they only travel in the very small circle, because no transportation means. Because transport, you need energy, you need engine. And then what invent engine? But that engine can be used with car, can be used for locomotive, because 因为瓦特发明的蒸汽机，它的燃烧跟动力是分开的，所以是很大。And then Faraday invent motor. So we have electric vehicles. It's earlier than ICE, because at that time it's no ICE. But it's very pity that the battery is not good, because at that time the battery is lead acid. So at that time the electric vehicle cannot go far away. And then Benz is very clever. Benz invented the ICE. What is an internal combustion? Internal combustion means 的燃烧和这个动力在一起 ，so that can be used for car, and then has been dominated for the last century. So people can driving around. So mobility is freedom. This is achieved, but it's not so happy because so many traffic jam, and the ICE use gasoline is polluting, not sustainable, and so many traffic accident. So it is freedom, but not so happy. And now we really can reach freedom and happy by the electrification and intelligence. Okay, so electrification, intelligent, and connected. So
what if the car you're driving today could predict your next move? Welcome to a world where your car isn't just a machine, but a smart companion, guiding your journey with intelligence and innovation. This is the world of intelligent electric vehicles, a world where technology and sustainability merge, creating a driving experience like no other. Intelligent electric vehicles, or IEVs, are a far cry from traditional vehicles. In essence, both serve the same purpose, to transport you from point A to point B. But that's where the similarities end. Traditional vehicles, powered by internal combustion engines, have been our loyal workhorses for over a century. They've taken us across continents, helped us explore the farthest corners of our world, and made our lives infinitely more convenient. Yet they come with their own set of challenges. Pollution, for one. Traditional vehicles emit greenhouse gases that contribute to climate change. They also rely on fossil fuels, a finite and depleting resource. And while they've seen technological advancements over the years, they still require a hands-on approach, a relentless need for driver vigilance. Enter intelligent electric vehicles. These vehicles are a beacon of sustainability, running on electricity, a renewable resource. They emit zero tailpipe emissions, making them a friend to the environment. But their intelligence is what sets them apart. Equipped with advanced sensors and AI technology, IEVs learn from their environment. They adapt to traffic, weather conditions, and even your driving habits. They can predict your needs, like when you might need a battery recharge or when to switch to energy-saving mode. They offer safety features like autonomous driving and collision prevention, taking a load off the driver's mind. In essence, intelligent electric vehicles are more than just cars. They're your co-pilots, your assistants, your guardians on the road. They offer a new kind of freedom, the freedom to enjoy the journey, not just the destination. And yes, they may be a new concept, a departure from the familiar roar of the engine and the smell of gasoline. But change, as they say, is the only constant. So, as we stand on the cusp of a new era in transportation, it's time to ask ourselves, are we ready to embrace this change? Are we ready to make our journeys smarter, cleaner, and more sustainable? Consider the possibilities of intelligent electric vehicles. Explore their potential, their benefits, and their impact on our world. Because the future of driving isn't just about getting from point A to point B. It's about making the journey intelligent, enjoyable, and kind to our planet. The road ahead is electric. The road ahead is intelligent. So buckle up and join the ride. The future awaits.
yes, our aim is mobility is freedom, but mobility also happiness. Okay, so as we at the automotive people go to the new journey, we have and then there's two stages. The first stage is electrification, and now we go to the second stage is intelligence and connected. Of course, the electric will still go ahead. So there are two challenges in front of us. Number one is how the electric vehicles can friendly interact with the grid. I think you are from China Light before. Now you are now this is 政治家但是 you have been in China Light before. So I hope this also has the China friends. How that the electric vehicles can be friendly interact with the grid. You know, the Huawei recently has very big, powerful charger, and they have two slogans. 它有两个口号，华为。第一个口号，一杯咖啡充满电 ，1 cup of coffee you charge full. Number two is 1秒1公里 you charge 1 second, can drive for 1 kilometer. However, you need the power plant to back up you because there's only the charger. So how that the vehicles can have a friendly interaction with the grid, because now the charger is 2 direction. So many cars on the road, it is a mobile storage. How can fully utilize this? This is the first challenge. The second challenge is with the cloud. As you can become intelligent vehicle, we should integrate the people, the road, the vehicles, and the cloud. 人, 车, 路, 云. How integrate? Okay, this is also a big challenge. Okay, so we have to further our research, from the fundamental research, from the fundamental materials, from the device to the system, and to the not only hardware, from also software. Now we have say software determined vehicles. SDV is called project. 软件决定一切，软件定义汽车。Because now software is very important. This is all the new journey or new challenges. For instance, we have to continue to our cutting research, and also now China has a big export for car. So it frightened some of the European and American, and this strengthened many regulations. Because our import this year is the largest in the world. So when we go abroad, we must be able to self-protections, and we must export the supply chains, not only the vehicles, but also the charger. And also we must learn the international law, how to be able to have a friendly relations with the other countries. So I have drawn the principle of healthy growth EV. First is innovation driven. 第一要创新驱动. And then the second is two-wheel driven, policy and market. At the beginning, must use policy. So China have very strong policy and strong subsidies. Okay. Of course, other countries have this, but in China, the policy is stronger. The subsidies is also stronger. At the beginning, you must have the policy, and then you must have the market. Only policy is not enough. When the market pick up, you must let the market. You must let the market driven. So this two, the policy driven and market driven, and then we must have the three components: good product, good infrastructure, good business model, and then number 4 is what I promote for network for flows. So 我用这种1、2、3、4， 1是创新驱动，2是两刃驱动，市场驱动和政策驱动，3是三好，好的产品，好的基础设施，好的商业模式，4是网融合，交通网、能源网、信息网、人文网要融合。Okay, so this is in line to achieve with the United Nations goals. There are 17 goals of the United Nations for sustainable development, and among these 17 goals, goal number 13 and 7 directly related to electric vehicle. And SDG 13 is combat climate change, and SDG 7 is ensure access to affordable, reliable, and modern energy for all. Okay, so China leads the global electric vehicle market, holding a substantial of 60% share of the global EV and over 50% of the global EV inventory. By the end of 2023, China has over 20 million new energy vehicles, with pure electric vehicles accounting for 16 million, representing 80% of the share. Additionally, China has maintained its position as the world's largest producer and seller of new energy vehicle for 9 consecutive years. Okay. Also, China have a breakthrough in high energy density power battery, vehicle lightweighting, fast charging, and increasing EV range and reducing charging time. Technology lacks the intelligent cockpit, the intelligence of vehicle, and automatic driving are contributing a more comfortable driving experience, accelerating the adoption of the electric vehicles. Okay, so that is I will not go in detail. Okay, yes. So I must speed up. I have no time to elaborate. So I skip up these figures. Now I go to Hong Kong. Hong Kong, we have the roadmap of population of electric vehicles and the clean air. Also, we have the Hong Kong Innovation and Technology Development Blueprint. So all this give us a breakthrough, a platform for us. Hong Kong, our target is carbon neutrality before 2050, and we are adopting clean and transportation technology. Now, in the last 2 years, we have jumped from 4% to 14% of the electric. Why? Because we have many policy. So you see the private car from 6.3 in the 29, but last year is 24. Why? Because we have many good policy. For instance, 1-for-1 replacement. If you replace your ICE car to EV, the government gave you subsidized. This one-for-one replacement. Okay, and also Hong Kong, furthermore, have a green transportation fund for 1.1 billion. Okay, and we have EV charging home subsidy scheme, a quick charging station scheme. Okay, so I will go to the EV powertrains. Okay. Anyway, I just got this prize from Seoul last week for recognized by my founding of the World Electric Vehicle Association. So, in fact, in the 1993, when I designed the concept vehicle, I proposed 3-in-1. At that time, what is 3-in-1? Motor, controller, and the transmission. But now it's expanded to all-in-one, at least 8 or 7. So all the motor, not only the motor, controller, and transmission, but also including the charger, the IPU, DC-DC, AC-DC. Through this integration, you reduce the cost, reduce the weight, reduce the volume, and also enhance performance, reduce the noise, and increase the reliability. Because it's not just the physical integration, but also the performance integration, Okay, so this is the powertrain. Now, inside the powertrain, most important component is our power electronic. For our power electronic, we are moving from the IGBT to silicon graphite. So you see many different cars, they are more and more using the silicon graphite because it is more higher efficiency, reduce the reduce the weight, increase the efficiency. So this is the power electronic. So this power electronic device, they continuously reducing the conduction loss, continuously reducing the switching loss, continuously improving the efficiency. Okay, so this is the power electronic. Then the chip. During the last few years, China can make all the chip. I think there are, for the advanced car, at least 30 chips to control the driver, to control the air condition, to control the music, etc. All the 30 chips now China can make. The China made chip is, we emphasize on the performance and the security of the chips. Then this is one of the example of this integration, achieve technology breakthrough in batteries, electric motors, and motor controller, 3-in-1, and then integrated electric powertrains. I will not go to the detail because the time from there is not only in the pure electric, but also in the hybrid. That is in the hybrid system, okay? In the hybrid system. And then what is our essential customer requirement? Competing pricing, low carbon consumption, long range, spacious, lightweight. This is our target to achieve. And also not only in China, because recently I go to Seoul, I visited Hyundai, also LG. Hyundai also the similar strategy with us. The whole range, by the platform, by the modules, the whole range of electric vehicles. It's very similar concept with us and LG also. LG, they are very, they want to become the boss of the EV in Korea. They do everything, unless the car did not do. Everything of EV component they will do, LG. Now, and also not only the car, in the 7 conventional fields, private vehicles, bus, boat, taxi, logistic car, construction car, sanitation, port, warehouse, airport, mining, all round of transportation, we want to be electrified. And not only the vehicle, but we want to electrify also the airplane and also the boat, the ship. Okay, so, and this is the truck. For the truck is another, because in the truck, it's not only the pure electric, but also the hybrid, but we also can remain the ICE. But the ICE is not by not by gasoline, but it's by the hydrogen or the biofuel. So there should be diversified technical routes, inevitable development plans for the powertrain system in renewable energy commercial vehicles. Okay, so now I will come to battery. Okay, battery of course is very important. Because this is the history of the battery. You know, from the lead acid to the zinc and then this is the cutting point, lithium. Then the first lithium is magnesium, then LFPO, then NCM. And now we will further go on. Of course, in the battery, there are 3 metals, anode, cathode, and electrolyte. So in the anode side, it's very active. So our from the NCM, now we will go to no cobalt, safe in lithium, low nickel, and enrichment. So that is our direction. From this NMC become no cobalt, only 2. Only 2, because N is no cobalt, so only N and C. Okay. So, and there's 2 directions. One direction is aiming for high power density. That is for the vehicles. So you can see the anode cathode is trinity graphite. The anode is the cathode is trinity and the anode is graphite. That is anode cathode. Different anode cathode, different anode cathode. And we want to achieve 50 kilometers at that time. We use high nickel trinity for the cathode and use lithium metal for the anode. But the other direction is cost effective. We not necessarily go so much energy density because this is for the powertrain, for the power storage. Because we have a lot of space in the energy storage. Okay, yes. So in this route, what we aim is cost effective, not necessarily very high. And cost effective is very important. So that means and also one direction is go to the solid state battery. I have no time to elaborate, you know, in the solid state it's use different anode and cathode, but we use the solid state of electrolyte. And the issue of the solid state electrolysis, the key issue is the ionic conductivity of the solid electrode is low, and the interface compatibility and sensitivity with the solid electrode metal are poor. That is the most challenging issue in the solid state. Okay, so this is solid state with different technical roadmap, and this is OEM declaration of how and when they want to launch the solid state battery, and also not only the material but also the structure. It can so flat fully utilize the space of the chassis, and also the battery design. In the battery design, in the old part is used battery design by method. You anode, cathode, and exit. You make experiments and then test. If not, you change. But now it's positive simulation and intelligent important. And I have a colleague, Zhao Haitao. Is your Zhao Haitao here? Maybe, yes. He is my colleague. You know, he invented one thing. It's what AI plus robotic. He can make a survey using AI, paper survey, project survey. What is happening all over the world, and then connect it with robotic, so he can make a quick decision. In fact, he has tried to use this method for Cortex, for working. Okay, so I think he can use this method now to make our battery design much quicker and better, much quicker and better. Okay. Also, can you use AI for our manufacturing, from intelligent manufacturing for digital modeling? Okay. So the batteries are already a hot topic, include next generation lithium-ion battery, new system battery, smart battery, battery system integration, thermal. This means we can have an intelligent battery, no matter weatherproof, no matter at hot weather, no matter at Xinjiang or at Hainan Dao, our battery is safe. Is safe. Okay, so this I just came back from, from Seoul, and this week, the IEA will have a conference, will have a workshop in Korea. They have this task force for the next 10 years, interoperability of bidirectional charging. This will become the IEA standard. Okay, so that is how that I say the vehicles and the grids should be friendly interaction. I have no time to elaborate this one. V2X, V2F racing, vehicle to load, vehicle to vehicle, vehicle to home, vehicle to building, vehicle to microgrid, vehicle to grid. Okay, and this is the slogan from the California Energy Commission. Our vision is charging should be easier and smarter than refilling gas. That is the slogan from the California Energy Commissions. Okay, so I to go to the intelligent connected vehicles. Intelligent connected vehicle is not just transportation bin, but it is nodes of IoT, source of big data, terminals of mobile broadband, and promoter of 5G, and itself is also computers. So you can see the key is the sensing. You must have a good sensor. Unfortunately, today the sensor, high-class sensor is expensive. So we have to continue to work to make a very good sensor, and we must have good computer to make a decision. Sensor is replacing our eyes and ear, and computer is replacing our brains, and we have the execution to replace our hands and foot. Okay, so that is electrification, AI, big data, and IoT. Okay, intelligent vehicle could empower the integration of energy and transportation. Okay, vehicle road car integration helps transform the role of vehicles in road traffic, a direction of the technology innovations, electrifications, intelligent common basic technology, or software. I think software in electronic will outgrow the automation. So we have called SDV. What is SDV? Software defined vehicle. This is already actual phenomenon now. Okay, so 5G is very important. 5G plus vehicle to everything. 5G to V2G. Okay, and cloud network integration. The cloud network also should be integrated. The cloud network integration and multi-cloud collaborative computing support enable efficient collaboration in smart transportation. The far-reaching significant smart car of Internet of Vehicles. So from the vehicles to smart vehicle, and then from the smart vehicle to smart transportation, from the smart transportation to smart city, from the smart city to the smart society. Okay, so it's smart city, smart society. So there's new attribute for electric vehicles, because in the old days, you can see, in the old days, the car manufacturer get profit from selling the car. But now, to get profit, not only for selling the car, they sell the software, such as your iPhone. They can get profit for the whole line. The core technology is also different. The core technology originally is engine, but now it's motor controller. And the supply chain is difficult. In the previously it's first tier, second tier, third tier, but it's linear. But now you all have software-defined vehicle. So in order to linear supply chain, you have round supply because you need software. You need software. Okay, so this is a schematic diagram. The EV industry ecosystem become bigger and bigger and bigger. This is the schematic diagram of EV industry integration. So I will go the last one, the integration of four network, four flows. The four network is the integration of energy network, information network, transportation, and humanity network. And flow is energy flow, information flow, material flow, and value flow. The concept is 1 + 1 bigger than 2. We are coupling and sharing, increase utilization of energy and asset, gain economic and environment benefit. Okay, so the key is this. The key is like this. This is social world, cyber work, and physical integrate. So you can transfer from data to information by the digital twin, but it's not enough. You should be able to further transfer information to knowledge by the so-called hybriding, by the help of the humanity world. And then you must update your knowledge. So we must further convert knowledge to intelligence by the conjunctive twin, also the help of the. So intelligence is very important. Now AI is like this, because you can think, you can expand, because you are clever, you have intelligence. So in this case, you can, in the energy, you can convert the waste energy to useful energy. For instance, you have so many wind and solar, the grid cannot absorb. Then you can convert, use the wind and solar to electrolyte water to become hydrogen. So by this, the key is the integration of humanity, cyber world, and physical world. And today AI will be a strong value for us. By the AI, we can implement the integration of 4 network and 4 flows. Okay, so it can push the industrial evolution. As you know, we have the first industrial evolution, invention engine. We have the second invention of electric power. We have the third industrial invention of computer, and we have fourth, is AI. But AI also very dangerous because AI can destroy our world. So we have to now, from the fourth, we have to evaluate to the fourth industrial. Fourth industrial, AI plus humanity plus environment. And my philosophy of 4 network and 4 flow and the integration of 3 worlds, cyber world, physical world, and humanity will help to evaluate from the fourth industrial evolution to the fifth industrial evolutions. That is the integration of physical world, cyber world, and humanity worlds. Okay, so this is our target: people-oriented, harmonious coexistence between human and nature. And as I say, we must have 6 eyes. I have 4 eyes, it's not enough. Okay, okay. It's not enough. We must put our eyes here. We must have a foresight thinking. Then second eye, we must foresight our eyes here to learn from the history. The third eye is here. We must have holistic thinking. 意境的思想, holistic thinking. And third, we must put our here because we are engineer. We must be able to implement. Then we put fifth eye here. We look Europe, we look America. Then we suppose 6 here. We look on Japan and Korea. We see everything. We can see everywhere, everywhere and everything. So this is 6 eye. Of course, the most important eye is inspiration. That is the most important eye. Then after inspiration, then we can have the second eye of imagination. After imagination, then we can have innovation. But I think the most important is what I promote today. That is integration. That is what the pair promote also, integration. Then we can implement, but we need money. We need investment. Thank you so much. Thank you for your attention.
Okay, thank you. Thank you, Professor Chen. What a wonderful lecture. Basically, or essentially, it is a short course, an intensive short course on energy and automotive engineering. So, without further ado, I would rather than spend more time for the audience to ask questions directly. Today, we have many online attendees. They will not have this chance to directly ask questions to Professor Chen. So let's open the floor for questions. Any questions? Yes.
Hi, Professor Chen. It's my pleasure to attend these distinguished lectures. I believe it's very inspiring. So Actually, I have two questions. Hope you can allow me to ask one by one. So the first question, actually, I asked myself for many years. As we know, you start the research and development of electric vehicles over 30 years ago. So it demonstrates excellent foresight and vision. So I wonder, what's the next direction in the next 30 years in the area of energy resolution and automotive revolution, just like you developed the electric vehicles over 30 years ago?
Another 30 years planning.
Yeah.
Yeah.
In fact, I have summarized, yeah. Because now we have to have a new journey. The new journey is not only electrification, but we also to go to the intelligence and connected. And not only for the vehicles, from vehicle, we go to the transportation, from the smart vehicle to smart transportation, from the smart transportation to the smart city, from the smart city to smart society.
Yeah.
And our ultimate goal is human, people and nature is coexistence. 人和自然和谐共生. That is for the benefit of our future generation. So we should be proud. Don't we? We should be proud. All of us should be proud because what we are doing is not for ourselves, for our future generation. Okay.
Yes, thank you.
Okay, thank you. My second question is, in the audience, there are many PhD students and also the research colleagues. So I think we are usually encounter the difficulties during our academic research. So I think, would you like to share some advice on us to how to solve the difficulties or how to face the difficulties during our research?
Yes, I think, in fact, in front of us, we have two ways. One way is very easy. Or in Chinese, we call 随大流. 随大流. That means you just, in fact, I have this experience when I work in Japan, in the Suzu, what do in Japan? In the morning, I go by train to office.
Okay.
Well, very big queue, and you just stand here because your back people will push you. That is 随大流. This is, but the other way is difficult, because it is many difficulties, but you can go to the upstream, to the up. That is you have to decide the way you go on. 就随大流还是我要爬到顶上? You have to make decision. 爬到顶上 is very difficult, and you have to prepare. Is a lot of difficulty, not only in the technical difficulty, but in the social, because you may be looked down by the other people. So you have to be brave. So the most important is you have to be brave. And how you prepare, because inside you have engine. You have to ask yourself, why you born in this world? You born in because your father and mother decide, but you have to make decision. 你既然来到这个世界上 how you make difference? This world with or without me, what is the difference? That is your engine. You must have the engine. And your engine, you can tap your 潜力, your potential. Everybody has potential, but some people don't accept your potential. As the Harvard, in the Harvard University, there's a motto: let everybody in the Harvard, the gold is shining, because you tap your potential. So you have to be always tap your potential. Then you can be brave.
Very insightful. Yeah, there's not only an engineering, it's a kind of philosophy. So always prepare yourself for the uphill battle. Okay, any other? Yes, yeah.
Thank you, Professor. I want to ask only one question. Is about the safety of the electrical vehicle.
Yeah.
That
Yes.
I don't know the detail for the battery, but how does it? Why does it fire when you get the impact from the outside? Is it the leach of the energy, and how to keep it safe in the future design? Thank you.
Thank you.
Yes. Of course, battery is the main issue. because, you know, in the battery, we have cathode, anode, and electrolyte. And the illiquid electrolyte, we have runaway. After a certain temperature, you are runaway. You cannot control it.
Yes.
So that is why we go to the solid state. Okay. So, but please, from the philosophic point of view, please don't afraid of some dangers, because oil, you also have dangers. Because in the whole society, in the whole way, there are two ways. One is development, one is safety. We have to take care, both of us, of development and safety. But if you always absolute safety, then maybe it's no development. If development too fast, that's very dangerous. So on the philosophy, you have to keep the balance between safety and development. So we also now, we step by step to address the safety issue. At the beginning, to be frank, at the beginning, the Chinese battery is not so safe, to be frank. But fast development. After fast development, now the Chinese, now number one. CDL is now number one. Originally, China battery is not so safe, but it's fast development. After fast development, you have money, you have experience, then you can improve your safety. Okay, so it is a dialogue.
So perhaps you haven't had sufficient time to brief us more about the solid state battery.
Yes.
Is it one of the directions to solve this kind of safety problem?
Yes. This is what, because you know, if your electrolytes use a liquid, that is a runaway. By replacing the liquid electrolyte to solid electrolyte, that is safety. But even solid state, I asked many experts, I'm not there. Even the solid state, you cannot also ensure 100% safety. But it's the runaway opportunity is less, no runaway, and it is suitable for high temperature, low temperature, safe everywhere. So now go to the direction is go to the solid state. But you know, as I have mentioned, solid state have many key issues. Okay, so please don't believe for some commercial statement. Okay.
Okay, thank you. Any other questions from the floor? Yes.
Congratulations, Professor Chen. You are as energetic as you were half decade ago when I was your student here. Unbelievable. I echo to what you said. Just because day before yesterday, I drove across the Guangzhou Daqiao using my new EV. The journey was definitely pleasant, enjoyable, and environmental friendly. So to echo what had been said for the last question concerning safety, a little bit impressive of what you said. We have to learn and from the our experiences to improve our safety. And last but not the all, as I have been working for the power station, treating tons of batteries. So as we know, it's necessary for us to properly dispose the batteries on a regular basis. Could I have your comment, please, Professor Chen?
Yes. So we have to know the whole cycle life of the battery, from the production to the recycling. What is the carbon footprint and what is the impact to the environment? Now, many rules is already there. And in fact, the EU will implement this. When you want to export EV to Europe, they will check your carbon footprint. So we have to consider the retirement of the battery and how to fully utilize the second life, third life. The second life is in the vehicle, electric vehicles, and the second life maybe is in the communication station or in the electric bicycles. So the first life, second life, third life, and finally dismantle the whole lines we must consider this, and we are now doing this step by step. Yeah, and in fact, in the Gongxinbu Ministry of Industry, they already have many regulations, and EU also put many regulations on this. So we are on the way to look on this issue.
Thank you.
Thank you.
Any other questions? So perhaps I will ask one question. Is that very interesting? Your Jilin project involving renewables,
Yes,
gravity storage,
Yes.
chemical storage, including ammonia and methanol.
yes, yes.
So this kind of project in green project integration, can it be occur or applicable to our Greater Bay Area?
Yes, I also amazing because I've been traveling all over the world and so many papers, but not the real thing. That is the first I saw the real thing happens. Okay, so by the integration of multiple, because if you only integrate wind, solar, and battery, is not enough.
Yeah.
Also, you see, in the power plant, battery, in fact, is not in line with the generators and motors and grid. Because in the power plant, the life cycle is 30 years. But our lithium battery was only 10 years.
Yes.
So this is not in line, you know. And also the contribution of battery, in fact, is limited. So only use battery is not enough.
Yeah.
You must use hydrogen. But only use hydrogen is not enough because hydrogen is difficult to transport. So you must use a swapping. You trans between the hydrogen, ammonia, and methanol. You swapping each other. Then become a green chemical. So from the green energy, green electricity, green chemical industry, you interlink.
Yeah.
Okay, and you leverage the cost. So I was amazing. So they appoint me as an advisor. I'm more than happy to look on this project, and this project will be commissioned next year. So there's a lot of things, and I hope through my capacity as an advisor, I can learn from them. Maybe I can bring some of the experience to our Great Bay Area.
So can Hong Kong play a role on that?
Yes, but Hong Kong must, because Hong Kong is so small. If you look in this one, Hong Kong should be of one vice member in the Great Bay Area, because we must link with the Guangdong so that have many energy source. For instance, in Guangdong have many chemical energy. Okay, so because the electric supply energy, the transportation energy, the industry, and the chemical should hand in hand. So in Hong Kong should play important role or leading role because Hong Kong is international port. But Hong Kong must link with the Guangdong province. So can make only Hong Kong is not enough. We make the whole region become a green region.
Okay, thank you. So due to time limit, may only allow one additional questions from the floor. Yeah. Oh, yes.
Greetings, Professor Chen. Thank you for your insightful speech. It's very inspiring for us, especially for the engineering philosophy and the trend of electric vehicles. And I have a question about the trend of EV types. So nowadays we have pure electric EVs like Tesla, whose power is only provided by the battery. And we also have the hybrid power cars like the Ching from BYD, a plug-in hybrid type. So I would like to ask that in your opinion, whether the pure electric type or the hybrid electric type will be the future trend of the EVs. Thank you very much.
I've been asked this question many times. My answer is like this. Maybe my answer is different with the other people's in China. My answer is that let the market decide. Because I also advise the government, please, I advise some of them, please don't make any rule for the government. You must go BEV, you must go hybrid. Let the market decide. Because the owners of the factory, he knows when I get the mass profit.
Yes.
Okay. So let the market decide. But on the overall, from the China side, we promote pure electric. That is what I advise the China government. Why? In Chinese, I don't call 万道超车 because I don't like 万道超车 because it's 像投机取巧，弯道的头，不小心你弯道会换车。我说是环道超车 because China is very lack in ICE. Even after we have a joint venture, it's still monopoly by the foreigners. So we cannot do very good ICE. We cannot do the very good transmission. ZF already monopoly the world.
Yes,
So we are so poor in the engine and in transmission. Why we don't go? We go to another road. 我换道，我不玩这个了。Because we are motor. In China, motor is okay. We can do better motor in China. Also battery. And it proves it's okay. So from the China, I think BEV is the main. You can see Toyota promote hybrid. And there's what they call, what the brand name is also very popular. What is the brand name? It's very popular all over the world.
Pierce.
It appears, yes. It's a hybrid. But hybrid is still is complicated. You cannot compete with the you cannot compete with BEV. So it is proof that the BEV is more competitiveness. But BEV cannot cover all applications.
Yes.
Because I say,
Yeah.
particularly in the commercial car,
Yeah.
I'm sure. Because the 工作环境不一样, road condition is different. BEV cannot cover all road condition. So instead of BEV, we still need hybrid. We need change extender and let the market decide. Because the owner of the factory, he know when I get the most profit. This is my philosophy.
Thank you. Thank you for your insightful comments. So it's clear that energy revolution and automotive revolution plays a crucial role in achieving the carbon neutrality. But there are still many challenges to overcome. Let's continue this important conversation and work towards a sustainable future. So now I give back control to our chairman. Yeah.
Let's give another round of applause to thank Professor Chen for his very inspiring lecture. All right, I will also take this opportunity to thank everyone for your participation and especially for those asked questions. I think all of you have contributed to this lecture. This is wonderful. So I hope to see you in the next pair lecture. And this lecture is adjourned. Thank you.